Dear students, in our last class we discussed about the simple pendulum. The simple pendulum is here, the time period of simple pendulum also there. The time period of simple pendulum is T is equals to what? 2 pi under root L divided by G. It means where G is the acceleration due to gravity, that is what? Constant. It means the time period of a simple pendulum is directly proportional to what? That time, it is length of the string is there. Okay. Now, the next concept is, if the simple pendulum is placed on a truck here. I'll draw the first one is, if it is a truck, yes, there is a truck here and one pendulum is placed on this. It is a stand and there is a rigid support here. One pendulum is just hanged like this. If it is like this, okay. Here a driver also there. There is a driver and truck is moving. Truck is initially at rest. I will take the first truck is initially at rest. The pendulum cannot oscillate from its mean position. It is always what? Rest. Okay. The first condition, I will take here the first condition. What is that? If the truck is moving with the uniform velocity. What is that? Uniform velocity. If the uniform velocity is moving with the uniform velocity, what about the acceleration? That acceleration is 0. Okay? With the uniform velocity, the acceleration becomes 0 here. Okay. If it is moving like this, if the acceleration is 0, what is the time period of that? The time period is nothing but that the time period is always what? The constant. The time period is constant. Why it is constant? It means what? There is the oscillation of a pendulum when it is moving with a constant speed. If it is moving what? Constant speed. Then what happened? The oscillation of pendulum is always what? It is also constant. It is its time period, its displacement is always what? Same. Okay, when it is there. Then what? Because there is no force. There is no force acting on the pendulum. No force acting on the pendulum. Why the force is 0 here? Because the acceleration is 0. If the acceleration is 0, then force is also what? 0. The force acting on this pendulum is also 0, but it is oscillating with a constant time period. The next thing is, if the truck is moving the different velocity, or if it is moving with some acceleration. Okay. Next part is the second part. If the truck is moving with a constant with the some acceleration A, now there is a pseudo force is there. There is a force acting on this pendulum. If the certain acceleration is acting on this pendulum, it changes its position. It means from its mean position, it is displaced like this. It is oscillating continuously. It just displaces like this. When it is moving the certain acceleration, then it means that the pendulum gets a new position like that. Like this. It is the new position. Now, if it is a position, always the acceleration due to gravity is there. Its weight of the body is mg at here. But we have to check what is the net acceleration due to gravity at this position. We have to calculate what? The net acceleration due to gravity or effective acceleration due to gravity at this position. But always the body is directed towards the ground. It is downward force is there, that is called mg. That the downward acceleration is there, that is called g only. G only. But here the body is moving forwards. It is also moving forwards here. But one thing, the acceleration is there along the x-axis and along y-axis there is a g, that is called a. Then this acts as what? The resultant of these two. This line acts as what? The resultant of these two. Now this is a right angle triangle. Now this is what? A right angle triangle. This is what? The resultant of A and G. Apply a Pythagoras theorem. If you apply the Pythagoras theorem, if it is G, here also G. If it is A and here also what? A. Then apply Pythagoras theorem. What about the G net? The net G is equals to the root of A square plus of G square is there. The net G is what? A square, root of A square plus of G square is there. It means what? The second condition is, what is that? If the truck is moving with acceleration A, with certain acceleration A, then the net acceleration due to gravity is, what is that? G net is equals to square root of A square plus of G square is there, or G square plus of A square. So what is the time period now? The time period of this truck, that the pendulum is 2 pi under root L is the length of the pendulum. It is always constant here, length of the pendulum. Then divided by that acceleration due to gravity become root of what? A square plus of G square is there. It is nothing but the addition of the two terms. It means the denominator is more. Then if the denominator is more, then what about the numerator of LHS? That become what? Decreases. This is the time period is decreases like this. The time period is decreases when it is moving with a certain what? Acceleration. The next thing is, when a simple pendulum or one pendulum is just it is dipped into the water, then what about the oscillation of that? What is the time period of that? Okay, here, when, next condition, when the pendulum is dipped, okay, when the pendulum is dipped into the water or any liquid is there, if you drop like this, okay, I will take one beaker or one something is there, one bowl or something, okay, put here, it is full of water and one rigid support is there, one pendulum is just dipped like this. Here the pendulum, I'll take, let the bob is there, bob of density of this bob, or it is made up of iron or something or anything. Here density is sigma. Sigma is what? The density of this bob. And another one is rho. It is rho. Rho is the density of the liquid. Any liquid. If you take water or any liquid is there. Okay. Next, volume of the what? That bob is there. Like V is the volume of the bob. Just like this. See here, if the bob is just dipped into the water, it is always directed towards the ground with some force. That force is equal to what? M into G. M into G. But one important thing is, here the number of water molecules are there. Those water molecules, it means just stops the body to move down. It means what? It stops, or it just resists the body to move down. It means what? If the body is moving downwards, the water molecules want it to move up. Like this. It means here, it is nothing but the force applied on the bob. It is the force applied on the bob due to the water molecules. The water molecules density, it is the density of the water, or it is rho, and the density of the bob, it is a sigma here. One thing, if just a drop one body is there, if it is a one body, that body is just dropped into the water, it is going downward slowly. It is going downward slowly due to the gravity is there. It means what? The gravity is more than the force applied by the water molecules. Okay? It is greater than force applied by the gravity. It means here the G is more than what? This FB or Fg is there. Fg is more than what? Fb. The net force is what? The net force is nothing but what? Fg is more than that, more than Fb, so that Fg minus of Fb is there. Fg minus of Fb. Then we have to calculate the net acceleration due to gravity. Then take here. It is called M into G net. M into G net. We have to calculate. Here M is nothing but what? The mass of the bomb. Then it is equals to F into G. Fg is nothing but what? The force due to the gravity. That is M into G is there. Then minus of Fb is nothing but what? The force on the bomb. It is due to, there are two conditions. It is due to its weight as well as the force applied by the water molecules. Two are there. It is nothing but what? M into G is there. Here the water molecules are there, and also the water molecules applying some certain force on this bob, that is equals to certain volume is there. This is the volume of the bob, that is V, and rho is the density of that is equals to rho, and also the gravity is also there. The weight of the body is there, that is what? Like that. Dy. Okay, I'll take like this. It is what? Mg net is equals to Mg minus of B rho into G, where B is called volume of the what? The bob. Next is, we have to calculate the G net. If the G net is there, Mg net is equals to Mg minus of V into rho into G is there. Then dividing both sides, M is G net is equals to, it is divided by M is there, M gets cancelled, Mg is there, then again M gets cancelled, then it become what? G, then it become what? V into rho into G divided by M. This M here in this condition, that M is nothing but what? The mass of the bob. The mass of the bob is here. The density of the bob called here the sigma. Sigma is called density of the bob here. That is equals to mass of the bob divided by its volume. Mass of the bob divided by its volume is there. Then what happened? Mass is equals to sigma into volume of that. Substitute the G net is equals to G minus of V into rho into G is there divided by what? sigma into V. Then again volume cancelled. Then again the G net is equals to 1 minus of rho into rho divided by sigma. G is common in both equations. Okay, this is it is G is common. Then we have to calculate what the time period. The time period of the bob when it is dipped into the water, that is equals to what T is equals to 2 pi root of L divided by G net or G effective gravity. That T is equals to 2 pi root of what L divided by 1 minus of rho by sigma into G. Now it is subtraction. It means what? It is the very much less. So what about the time? The time period is what? Increasing here. Increasing. The time period is increasing in this condition. Next part is. The next part is nothing but what is the time period when a metal charge or metal particle or pendulum, if the pendulum is a metal which contains the positively charged particle, which is a positively charged, when it enters the electric field, if the electric field is in the same direction of that gravity, or if the electric field is in the opposite direction of the gravity, there are two conditions. Next is when a positively charged bomb, take here the positively charged bomb, or consider that bomb or a pendulum is just placed into the what? The electric field. If the electric field is there, sorry for that. Placed in electric field. That electric field should be uniform electric field, then directed downwards. If both are here, it means the electric field is downwards. If it is the uniform electric field, is there, when a charged particle is there, a pendulum is there, that pendulum is just enters the electric field, it is an electric field, but the pendulum, it is always directed towards the ground, like this. That ground is nothing but the force is mg here. It is what? The positively charged particle or the positively charged bob or pendulum is there. Electric field is also there. Both are in same direction. What is the total net G is here? What is the net G? Then we have one form, that electric field form is the force per unit charge. In second year, the first chapter is there. That electric field is nothing but what? The force per unit charge. If the force, what is the force here? The force is equals to electric field into what? The charge. Electric field into a charge is there. Then both are in same direction. If the same direction, these two forces added. If these two forces are added, it means it is the force here. The force become the E into charge. Another one force is there, that is mg. The total the total force in the downward direction is mg plus of E into Q. mg plus of E into Q. Then the force is there, the total force is also there. What about the G net? Okay, we have to calculate the mg net is equals to mg plus of E into Q is there. Then again divided by m here. If you again dividing m, then what happened? G net is equals to G plus of EQ divided by m, where this mass m is nothing but what? The mass of the ball. Again, the mass of the ball. Then what about time period? The time period is T is equals to 2 pi root of what? L divided by G net. That G net is G plus of EQ divided by m is there. It is addition. Addition means its value is, the denominator value is more than the numerator. It is more than the numerator. Then what about time period? The time period is again decreasing. The time period is what? Decrease. Time period is decreasing. Next thing is if the electric field is in opposite direction to the pendulum. Okay, if the electric field is in what? Opposite direction means upwards. If the electric field is upwards, it is opposite to the gravity like this. If the electric field is opposite to the gravity, then the pendulum is there. There is the pendulum. Always the acceleration due to gravity is there. The force is mg. It is opposite. Here it is a positively charged. Okay. Then this electric field. What about the force? The force is in the upper direction. The force in the upper direction. That force is equal to again what? E into Q. If it is E into Q, but it is opposite to the mg, so total net force is equals to minus of E into Q is there. E into Q is there. Then finally, what about G net? mg net is equals to mg minus of E into Q. Then again dividing what? M. Dividing m, it means G net is equals to G minus of EQ divided by m is there. If it is G net, then what about the time period? Now the time period T is equals to 2 pi root of what? L divided by G net. The G net is equals to what? Here this form is G minus of E into Q divided by m is there. There is subtraction. When you subtract that EQ divided by m from G, this value become what? Less. If it is the denominator is very much less, then what about the time period? What about the numerator? It become more. Your answer is also more. That it become that T is equal to what? The T is always here increasing. Time period is increasing. These are the conditions of the simple pendulums. Then we'll discuss about the next very important and the last concept of this chapter, that is the types of oscillations. The types of oscillation, there are two types. One is free oscillation, or also called undamped simple harmonic oscillation or undamped oscillation, and another one is damped harmonic oscillation. What are those? If one thing, I'll write one simple thing is here. Types of oscillation. First one is free oscillation. First one is free oscillation, or it is also called undamped harmonic oscillation or undamped oscillation directly. Undamped oscillation. Undamped means there is no change in amplitude and frequency and energy of the particle executing simple harmonic motion. It means one particle which is just starts from its initial position, its amplitude cannot change. It never changes up to the time infinity time. Up to when it is moving up to infinite, its amplitude is always the same. It means there is no loss of energy. There is no loss of energy here. If it starts from its initial position, there is the time axis. If the particle starts from its mean position like this, here the amplitude, the position or the amplitude is the maximum displacement. This position are always what? Same. In free oscillation or undamped oscillation is nothing but what? The oscillation of a particle. Oscillation of a particle in which what? The amplitude, frequency and energy cannot change or remains same, or what? The remains same. Remains same. If the amplitude of the one particle which is moving in undamped oscillation, that is considered as A. If it is A, then what is, if it is amplitude? If it is amplitude, then what is the equation of this damped oscillation? Sorry, undamped oscillation. Equation of damped oscillation, its equation is displacement equation along the x-axis. I take here only x. That become A is an amplitude into cos of omega t. Into cos of omega t. Then what about the energy? The energy of that undamped oscillation is 1 divided by 2. K is equals to m into omega square. Okay. K is into what? The equation is the maximum equation. The maximum displacement or maximum displacement is here. That is A square. A square. You can take directly. It is A square. This is the total energy. It means there is no loss of energy. There is no loss of energy. No loss of energy. Next thing is damped oscillation. Here, the damped oscillation is nothing but the particle starts to oscillate from its main position with the decreasing amplitude. If it is initial amplitude is A, after certain time, it just decreasing. After that, finally it becomes 0. Finally, it becomes 0. That is called decreasing amplitude. Okay. Now, the oscillation of a body, the oscillation of a particle in which amplitude amplitude is decreasing with time. That point is very important here. With time. It's called what? Damped oscillation. Damped oscillation, it means what? Here, if the amplitude is decreasing means what? If the amplitude is decreasing means the energy is lost. Energy is continuously losing here. Here the energy is losing. Energy can lose. Okay. One diagram is there. If it is the mean position, if the particle starts to oscillate from its mean position, initially the amplitude is more here, like this. After one cycle, after one period, its amplitude is just decreasing like this. After one period, it's decreasing like this. Continuously, it is decreasing and become what? Zero. This is the decreasing the amplitude of the particle, which is oscillating continuously. It means what? The amplitude is decreasing, the energy is also decreasing here. The energy is decreasing, lastly it is finally, it becomes zero. It means the energy is continuously lost. Next, what is the equation of that? Equation of this damped oscillation, I will take here only x is equals to, if you want that amplitude, if amplitude is not constant, it means it is continuously decreasing with some exponential. What is the term here? I'll write the directly form is there. One exponential form is, if A is an amplitude of that, it is a decreasing amplitude. How much it is decreased? That is some exponential. That exponential is nothing but what? It is E into minus of B divided by 2M into T is there. It is in the general, it is one general form is there, into cos of omega dash into T plus of some phase is there. Here minus B by 2M, it is nothing but it is one general form. It is in the form of x is equals to A into E into minus of, it is minus of omega square into T is there. Minus of omega square into T. Then it is, if it is omega square, it is, omega square into T, omega into T. Then it is cos of omega dash into T plus of phi naught is there. If it is omega dash, we also take the omega dash. The next is, it is equation, then what about the energy? Its energy is simple. Here this complete form is an amplitude. And complete form as an amplitude. Then energy of that. Its energy, we already written here, the one E is equals to 1 by 2k into A square, where A is the maximum displacement. Here also amplitude is there. The coefficient of that amplitude is completely what? The coefficient of the harmonic function is completely what? Amplitude. Then the energy is also there. Its energy is 1 divided by 2. K is there. Its total amplitude is here. That is equals to what? A omega dash is nothing but, here there is a one form, that is e to the power minus of B divided by 2m. Okay, this is completely one form. Omega t is there, only omega is form. And here then another one is into that, there is into t is there, into t whole square, because k y square, that k a square is there, so that it is square. If you simplify this equation, then k is equals to a square into e to the power of minus b into t square. Here 2 is there, divided by 2m is there, then 2 gets cancelled, that become what? M. This is the total energy of the That's simple harmonic, damped oscillation of the particle. In next class, we'll discuss about the another type of the oscillation, that is called the forced oscillation. Next is the forced oscillation. This is the third type of oscillation. First one is what? The undamped oscillation, or also called free oscillation. Second one is damped oscillation. The third one is forced oscillation. Forced oscillation means that body starts to oscillate with some force by applying certain force continuously. I'll take here the one body. If it is a particle, if it is continuously oscillating like this, the pendulum is there. See here, when you apply a certain force on this body, when you apply here like this, if you apply a certain force like this, it starts to oscillate. If the force is applied on this is only once. Okay, one time the force is applied, it means what? It is continuously oscillating like this. Oscillating continuously. It is called what? Now this particle starts to oscillate with the oscillating, that is called the natural frequency. With the frequency that is called natural frequency. But the body, it means we want to oscillate this body continuously with a certain force, that is called what? The forced oscillation, that is other than natural frequency. That frequency is called the driven frequency. It is called driven frequency. It means what? The body is continuously oscillating like this, which by applying continuous force is there. If it is continuously oscillating, means this is the forced oscillation. It means the body starts to oscillate with the other than a natural frequency. That is called what? The forced oscillation. Its form is, its definition is here. The particle oscillate other than what? Natural frequency. Natural frequency. That natural frequency, call it is omega. That is natural angular frequency, that is called omega. And it means, but natural frequency other than natural frequency is called what? That frequency is called what? The driven frequency. Driven frequency. This driven frequency is other than that. It may be more than the natural frequency or less than the natural frequency is there. That is called d, omega d is there. This type of oscillation is called what? The forced oscillation. This type of oscillation is called the what? Forced oscillation. Forced oscillation. According to this one, its equation, that forced oscillation is equals to what? F naught. This is F naught is an amplitude. That it means the maximum force is there into what? Cos of omega t plus of, if that it makes a certain phase, that is phi. Where the amplitude is there, we have the amplitude of that given equation is a force, and another one is the displacement equation is there. The equation of the displacement of the particle, which under the forced oscillation. Displacement is, that is called is x is equals to, that is a into cos of omega t plus of phi naught. In this forced oscillation, that value of a is different. It is with the f naught, this value. That is equals to where it is with the angular frequency, driven frequency, and also this force. A is equals to, call this is f naught divided by, where m is the mass of the ball, m is there. Call it is m or m square, okay? M square into bracket omega d minus of omega square d, omega d square minus of omega square plus of b square into omega d square. It is under root. This is the value of what? A. Where in this equation the driven frequency is more than what? The natural frequency. It means the body starts oscillating very fastly. Okay, if it is very slowly with the force, that becomes what? Driven frequency is less than the natural frequency. It is less than the natural frequency. This is the equation of the amplitude of the forced oscillation when the particle is under the forced oscillation. I'll draw one diagram for this one. Very simple. That is the graph of the forced oscillation. Along the y-axis there is the displacement of the particle, and along x-axis there is the time here. Along x-axis there is take here time. If that particle starts from its origin or something is there, it takes the time is here or 0.5 seconds, or it is 1 second, it is 1.5 second, or something is there. A displacement, it may be 1 centimeter or 2 centimeter or 3 centimeter, something is there. It starts to oscillate. It means I will draw first one is the natural frequency like this. If it is a natural frequency, if it is what? The natural frequency, that is called the omega. The driven frequency is may less than the natural frequency or greater than natural frequency. Okay, call this as a natural frequency omega, or it is like this, or it may like this, or it may like this, it may be like this. Now this is called this frequency as it is a or B and C and D, it is E or something is there. Here A is greater than what? B. B is greater than C. These all A, C, D, E, all of the driven frequency. Consider B as a natural frequency. It means what? The driven frequency may greater than the natural frequency or less than the greater frequency. What? Driven frequency or natural frequency there. Now with this, that oscillation chapter is over. Then you have to solve some more problems and practice some more problems are there. Okay, thank you one and all.